I'm excited about a lot of things. I'm excited about, so this is not, how do I say, this is not officially sanctioned in that I don't have consensus of the faculty, but we always used to say Media Lab is demo or die versus traditional academia, which is publish or perish. But there's a movement recently to change it to deploy or die. Because what's happening, and this is a lot of what Solid is about, I think, is that as the cost of manufacturing and the cost of prototyping, but the cost of actually deploying is going down. You can get beyond prototypes. And the Media Lab was really important because we had all of the resources and the equipment here to get to prototype. But a lot of our things, whether it's the e-ink for the Kindle or Guitar Hero or Lego Mindstorms, we create the prototypes and some big company or some researcher would take it into another institution and turn it into a thing. And so demo was as far as we got. But now we have kids going to Shenzhen and learning how to manufacture, and we have student startups kickstartering things like Farm Labs, and that we can actually deploy. And so I think what's fundamentally different is that as you start to think of manufacturing as something that you can do and think about and learn while you're still here, it shifts the focus, and so Neil Gershenfeld, who's going to be speaking, his class I think is one of the most popular classes at MIT, how to make almost anything. And then Dave Meadows has a DIY manufacturing. But I think that we want to go into full-blown manufacturing as a thing that we do at the lab. And to me, that also pushes innovation to the edges, and not just in big companies and big research labs. And in fact, you don't have to be in the Media Lab or MIT. That we want to connect with a broader network of these. I don't even know what to call them, because when you say maker's movement, I think is great. But it's a lot maker movement. A lot of it's about super customization, right? It's about making stuff for yourself and your friends, and it's a smaller scale. But to go into these different types of manufacturing, but at a street level. Street manufacturing may be a better way of saying it. So I'm excited about that.
Less about sort of the gratification of just making something than about the gratification of putting something out. So I really like the way that you're talking about manufacturing as deployment, because in the analog between software and hardware that we're thinking of, where something like a software prototyping and development and deployment process becomes a hardware prototyping, development, deployment process. Manufacturing is the deployment, the way that you would deploy software on a bunch of Amazon servers or something. You deploy hardware, your hardware idea, your physical world idea through manufacturing. And so it's crucial to understand that step.
Yeah, and it's interesting. I haven't been, but my students tell me that in Shenzhen you get these kids making cell phones as kind of, instead of making an internet startup, you make a cell phone. And they're sitting there on the factory floors, working almost directly on the manufacturing equipment, knocking out a couple thousand units, going down to the stalls, testing it, looking at each other's stuff, copying it, going back, revising it, and it's almost like agile A/B testing and agile development for hardware. And so I think there's a really interesting metaphor there. And then the other parallel that I see is the new, like the Samsung pick and place machine that Lemore Fried has. I mean, it's a factory in a box, and it's Samsung's manufacturing technology being sold to anybody who can afford it. And although it's not an exact parallel, it reminds me of Amazon Web Services, where Amazon was taking their core technology around scaling and making it available to everybody. And to me, those are the kinds of things that are making hardware more and more like software. And then and that also allows, I think, sort of an impedance match that didn't happen before, because it used to be that you would sit around and talk to people who developed hardware on a 5-year roadmap, and they didn't care about your requests for APIs and SDKs. But now it's different.
Right, absolutely. No, that's right. It's like the kind of modularity that we've seen in software over the last 15 years, where you have a bunch of open source modules and you put them together and you can stand on someone else's expertise. It creates this kind of comparative advantage where, just as if you're developing software, it's better to let Amazon which is an expert in running servers, run your servers. And if you're an expert in writing machine learning algorithms, then you write the machine learning algorithms. In the same way, Amazon Web Services for manufacturing has come up a few times in the way that people talk about sort of the Shenzhen supply chain ecosystem. Going to a company like PCH, for instance, that can take your idea and realize it in the supply chain there, so that you can be an expert on designing and marketing your piece of hardware, and someone else can be an expert on the matter of like tooling and distribution and so forth. It's extremely powerful.
I think the other piece that's emerging, I mean, we have experience already, I mean, is around intellectual property, copyright, and patents. We have a little bit of experience from, having done this in software, and we have the, open hardware definition and a lot of stuff in this space. But I think that some of the older school companies have a variety of levels of experience with this, and this I think is something that, having been at Creative Commons and other places, is something that I'm interested in seeing the dialogue around, because I think that is also the other key to the lowering cost of innovation, was the fact that you can build on top of free and open source software. And you see pieces of this happening in the hardware space, but it's obviously slightly different because you have that manufacturing component that connects to things like Arduino and everything.
When you talk to your students who are going to China and building things, what is it that draws them to getting involved in manufacturing?
That's a good question. I mean, I think that it's much more satisfying, fundamentally, I think, to see thousands of your thing than one of them. I think at the Media Lab also, we have a lot of, we have a consortium of members that are basically big companies that come and they say, I want that, can I have a few of these? And we can. But now what I'd like to be able to do, even if we don't go into full-blown manufacturing, is to be able to, create enough so that we can do real trials. And I think a lot of people in the sort of deploy part, whether they're medical sensors or gadgets, would love to test it on a couple thousand people, because that's a whole different set of data that you collect about somebody than just testing it in a small focus group. So there's a bunch of reasons why it makes sense, but I think the main thing that I've heard from the kids that have gone is just the inspiration of designing for manufacturers. So there's like, Bunny on his blog was talking about this $12 retail price cell phone with 5 megabytes and MP3 player and OLED screen and all that. I mean, you can't design a $12 cell phone without deeply understanding the equipment that it's being manufactured on. And I think that, our students just, the idea of just understanding and designing directly on the manufacturing equipment feels so much more real than just fabricating a prototype.
Right. So what do you think is the role of expertise in that? Is there going to emerge a single person who understands the design and prototyping and manufacturing of hardware and the deployment of software to work on it? Or is this again going to become sort of a stack of modules of expertise?
I think it's a really interesting question. I mean, I think it's, I do think there are certain layers that are going to collapse. I do think that understanding manufacturing is going to be key to design, just like understanding the internet has become key to running a company. And that so that will bundle. But then, to your point, you do have modularity, and I think the software people. But it's what's interesting is you can create layers of modularity, but if you get rid of the unnecessary complexity, it actually allows you to understand more. So, for instance, Ruby on Rails, I would argue, probably increased the number of people who felt they had expertise in making websites, because it made it easier. Although it does layer the stuff and simplifies it. And I think part of this, and this is kind of the Ruby on Rails design principle, is that the default sort of works. So if you could create it so that the hardware components, even though they're components, the default sort of works. So you don't actually need to understand it completely. You just need to understand how to interface with it. And a lot of tools, that's enough to actually be able to use it. And so I think that in a way, for the designer, it will become easy to kind of get your arms around it. And I think it's still tricky, because when you sit on the factory floor in Shenzhen, they're using, like plastic soda bottles and stuff to like make the stuff work, and it's still not that shiny. Yeah, it's still pretty improvised.
Yeah.
But and so I think there is a lot of deep expertise once you get into the nitty gritty. But that's true with all of our, like every Ruby gem, there's a lot of expertise stuck in that thing, and only a few people need to know it in order for everybody else to benefit from that knowledge.
Right.
Yeah.
I think that's I think this is sort of a thread that's been lost in a lot of the conversation about hardware, and it frustrates people who see themselves as starting with first principles and going into kind of a scientific approach to developing some new device or new piece of hardware or new machine. That we are approaching a level where it's easy to feel like an expert in hardware. It's easy to buy the modules for very little money and sort of like tinker them together into a prototype. But that is what I think separates the people who are making a novel and fun, iPhone accessory from people who are doing something really impactful in, solar power generation or wind power generation or something like that. Is the ability to start with something really basic and sort of understand that and go up from there and make an advancement in the basic level.
And I won't name names, but a lot of internet startups start out by launching something that's actually a prototype, and then they hit the wall once they realize that they need to now rewrite the thing as a production system that's scaling, that's using Hadoop and everything like that, and that's a completely different kind of thing. And I think it's similar in manufacturing. I mean, I think in a way, manufacturing is a production level thing of, and I think there are similarities in software, and also that every level of scale has a different level of expertise, and the number of people who understand it becomes smaller and smaller. And I think that's just that is true. But the neat thing though is companies like PCH and AQS and others are trying to fill that gap by creating an interface, and it'll be interesting to see how successful they are.
Yeah, exactly. And I think that opens up room for the kind of audacity that's fun that people go for. A lot of people point to Tesla, which has accomplished something really incredible in being sort of a venture-funded startup with a full-scale automobile production line, right? Which is crazy. But then you can't necessarily say that the next step is for someone to develop a passenger jet the same way. I mean, there are this incredible sort of like pyramid of expertise, and it looks from experience, from sort of hand-picked stories, that anything is possible along those lines by sort of snapping modules together, and that I think we're about to go into a really interesting period of seeing what plays out that way and what doesn't.
Yeah, and I think one of the things you'll hear in Neil's talk is that he's very much into assembly and the idea of assembling modules or small parts, and it ties to your sort of modularization. You can pack a lot of expertise into modules, and depending on how you chunk it, and so it will be interesting because it's also design at scales, because you can have modules that are nano size, you can have modules that get snapped together to build airplanes, and kind of like Legos. I mean, the modular snap together part is where the error correction happens, and in a way, a lot of it is about error correction, because I think even without test-driven object-oriented programming, the idea is that each component is tested, and that you should be able to assemble it. And if you run the test code properly and build it properly, it should allow you to construct more with less failure. And so it'll be interesting to see how the hardware equivalent of that plays out.
Yeah, and I think companies that are building sort of heavy equipment in particular, we see this in the automotive industry, and it's been true for a long time in aviation, I think, are looking for that kind of modular approach where you can do error correction at the divisions between things, avoid impedance mismatches, and for instance, make it possible to construct the entertainment system in a car on a totally different time scale from that of the car. It takes 10 years to design a new car from scratch. Which is a lot of the reason why your in-car navigation system is just a terrible, piece of software, because it was designed, 8 years ago as part of this process.
And that totally reminds me of the internet. Remember before the internet, like the Minitel system or the Captain system in Japan, you got these telephone companies that did the wires, that did the hardware, did the software, did the content, and you can't, even if they were on slightly different timescales, the same brain can't comprehend because each layer is at such a different timescale. And I think the auto companies are the same way, where they're like the mainframe computer companies or the telephone companies of the past, where they have this monolithic thing where they feel like they need to be controlled, and they have there's some reason for it, because they have the safety issue and things like that. But the idea of unbundling it in layers and having each layer going at a different speed with a different risk profile with a different group of people, I think they're. But when you talk to them, they're all thinking about it. I think they just haven't been forced to jump in. I think in a way Tesla is an interesting driver, because it's showing that you can make a car company in a new way. And Tesla is also not unbundled as much as it could or should be, but I think it's going to drive people to think about it. So,
well, and this is another way that I say something like that, and that's one of these audacious things that sort of software people in California say, and then you go and visit one of the sort of big three in Michigan, and go to their R&D facilities, which are like miles and miles and miles of low-slung buildings, right? And they're like here at MIT, you walk into them and it's just a grid of wet labs everywhere. And this is the wet lab that tests adhesives for attaching upholstery to steel. And this is the wet lab that tests the gripability of different steering wheel covers and stuff like that. And you sort of survey this and go, wow, developing a car is just an unfathomably complicated thing. It's not at all simple to say, oh, you just need to split this into some modules and get people to develop it separately.
Right. And yeah, I had a similar great experience. I went and visited State Farm, and I went to see their automobile testing and repair center, and they were showing, I mean, they get every single car, they completely strip it down, and they even had really high-end cars as well. And it was interesting because then they have to pay for the insurance, the repair. So they have an incentive to make things easier to repair. So they would send back reports to the automakers about how they could redesign this piece to make it easier to repair, and they would upgrade it. And but their whole place was just a whole bunch of car nerds just stripping and rebuilding and crash testing cars, and that was also, I had a similar, but maybe slightly different experience, was just like, wow, there's a lot more to this hardware stuff than debugging's harder. You know?
Exactly. When you look at the sorts of students who are going into building hardware and getting interested in manufacturing, are they people who had some interest in hardware and tactile stuff to begin with, or are they recent converts to it from software or some other discipline?
So I think they come from all places. I mean, I think what happens when you get to the Media Lab is you get sort of immersed in an environment where people play with hardware like people play with software. And so some of these people are just people who have a software idea and realize that they can control the experience better if they reach into hardware. Some of these are hardware people who are going into software, and other people are musicians and experienced designers and people who are interested in learning, and the fact that you can play with hardware is just a new thing that's been added to your portfolio of tools. And so I think that's the right way to approach it, and I think that having both hardware and software design kind of in the same place is what is generating this new category of hardware. I mean, look at the Nest or any of these great tools. Well, Apple, right? I mean, so and I think what's been hard is in the past, in academic disciplines, they kind of were separated. You had mechanical engineering and you had computer science, and I think that putting them together is really important. And the Media Lab is very much a tinkering and learning through doing sort of place. So you see a lot of rapid iteration and a lot of peer learning where the kids are teaching each other. It will be interesting to see. I mean, I can see Silicon Valley picking it up quickly, and Stanford and other places have places where some of this happens, but I do think it isn't in the DNA of Silicon Valley yet at the level that it could be, and I'm interested to see how we can contribute to that, because I think it is a little bit more in the DNA here.
Right. It presents these cool opportunities for design, where you can design beyond the screen, right, and not be constrained by having a keyboard and a screen mediate people's interaction with your software at heart, right? Like something like the Misfit Shine, which is this wearable that has no screen and no buttons, and you interact with it by tapping on it, and then little tiny LEDs come up around the edges, is a really cool example of that. If you have control all the way down to the software, all the way down to the hardware level, then you can design this full integration of hardware and software that just forgoes that kind of the full integration of hardware and software that can do something really novel with design and interaction. Yeah. And there's also this side of it too, where design beyond the screen means you're using more machine learning and just foregoing interaction altogether, right? Something like Google Now, where it gives you an alert that tells you how long it'll take to get to your next appointment without you interacting with the phone at all, right? Or you could imagine that an autonomous car would work this way as well. You say, I'd like Indian food tonight, and then it goes through a handful of the interactions that you would have to go through yourself, looking up an Indian restaurant you'd like based on your preferences, finding a recommendation, finding directions to it, putting the address into your GPS, and then driving there. Each of those is an interaction interface that's being replaced by a machine in some respect, right?
Yeah, and I think in that sense, the idea that user interface is something that you're paying attention to, the screen, I think is pretty narrow, because we're so capable of, like driving a car is a very complex parallel processing task, and somehow we're able to do that. But when we think about human-computer interfaces, we've typically focused on your finger and your eye, but that's a very narrow band. And so there's one part which is a lot of this autonomous things happening around you, but you also have your whole body. You have sensors. The computer should know when your blood sugar is low, and your body can be communicating. And there's also sort of peripheral vision. There's sort of pattern recognition. So I think what's going to be kind of interesting is to see how the future of interface, because I think, for instance, there's a lot of complexity that you can't verbalize or you can't scrawl with a little pen, but that your body can somehow express. And so I think that and when we call it bionics, we like that sort of slightly retro word, but interfacing with the computer, with your brain directly, or with your body connecting to your nervous system, sort of embedded chips, that's going to create a much more sort of systems-oriented interface with us. And I think that's that's coming really soon. I mean, that's an area that we're actually looking for somebody that's, we're doing a faculty search right now for somebody that does embedded circuits or brain interfaces. So.
Interesting. When you have an approach where you have all the data available for a process or a business, and just sort of mine it, you can come up with something rich and unexpected that no human analyst would have thought to ask. There's an opportunity in designing these systems, I think, to sort of gather just a phenomenal amount of data and look for the same kinds of interactive cues, the same kinds of signs that are unexpected and unintuitive, and make good use of those.
I think also, as we get more data, one thing that I want to do is require sort of the equivalent of an environmental impact study for every new technology. So, because I think in the past, what you do is you build something, and if it sort of benefited you locally, you didn't really care what it did to the system, because the world was robust enough and resilient enough. But now we have all the stuff that we make that could screw a bunch of other things up. And so you may be saying, okay, here's what this thing does. But I may say, okay, well, it touches 3 of these other systems. It touches the agricultural systems. It touches water supply. Touches this. Let's look at the data and see how your system is affecting other things. And this could be I'm on the board of some foundations, and it could be medical interventions in a village, or it could be a new tool on the internet. But I think we now also have the data to look at these impacts, and I think it should be a design principle and to be sort of systems oriented and to think about the overall impact of everything you do. And I think, you know, that people who work on the internet kind of already have that, right? I mean, the do no harm thing. I mean, you can build stuff, but you don't want to build stuff that ruins it for other people. Right. And because it's really easy to do. But somehow we tend not to do it. But I think that as the hardware community gets into this, I think they're going to need to join this philosophy. Mm-hmm. But also we have the tools, I think, to measure it. So.
To measure and approach and sort of and enforce some of that philosophy. Yeah,
and I think people should be taught that, because I think when you're in school and you're learning about how to make things, you know, you just order things from the internet, you put it together, and when you're done, you throw it in the trash. Yeah. But you don't think about that whole supply chain. Right. But now it's very easy to understand it and say, oh, well, maybe I should be using this part instead of that part, or maybe I shouldn't be throwing in the trash. Maybe we should be repurposing this. And so, so you, without being all hippie about it, I think you can create a sort of systems thinking approach, because I think if you do think about the system, then you realize that everything that you make is sort of whacking the system, and you want to make sure that you're not whacking it in a bad way.
Right. And it's a lesson you can learn as you go in, the way that there's been an influx of people who use systems like Ruby on Rails to start becoming sort of web experts and building stuff on the web. There are these tools that let people come in and build stuff in the physical world and take advantage of these supply chains, start manufacturing things. And it's a lesson that an entirely new kind of cohort of people has to pick up. Mm-hmm.
And I think also that's assuming all good actors. There's a lot of bad actors, right? And so I think the other part about thinking in systems is to try to create systems that are resilient to attacks. And that's another area that it's interesting, because if you look at the vulnerabilities, it's now getting into firmware, where you have a lot of these firmware exploits, and it's getting closer and closer to the hardware. And there have always been versions of hardware exploits and stuff like that. And with all this NSA stuff coming on, I think also as a community, we need to think about how to manage the system so that it develops an immune system as well.
Yeah, the firmware has never been exposed in quite these ways before, but it's quite easy to get at it now, and people are interested in it, and they're developing the knowledge that it takes to get into it.
And then there's going to be a crossover into biology soon.
So. Right. We're thinking that might be a theme in Solid 2015. There are already a couple of synthetic biologists on the program this year, and judging from the kind of faint signals in our community, I think bio sounds like something that everyone is watching. Excellent, awesome. Thanks so much, Joey, and looking forward to hosting Solid with you in May.
I know. I think this is going to be totally amazing. It's a convergence of all these different worlds that I've been working with. So
it really is. Awesome. Thanks so much.
Cool. Thanks.